Understanding the 3D Euclidean space is fine and all, but once you have a few equations to start working with, and you need to find areas, volumes, and whatnot, then things start to get a little bit more complicated. So I prepared a few examples, and we're going to go over each of the examples here to sketch what the equations or expressions that we have describe. And as we do that, I'm going to discuss why things are what they are. So z equals 3. What does that equation is describing? This is describing all points in the Euclidean space that have z coordinates equal to 3. So what points are in there? Just thinking through now. The point 0, 0, 3 is there for sure, because in that point z equals 3. So that point's in there. All other points that are at the same height as z equals 3 will also be there. And so I can move freely in x and y in any direction, and I'll still be satisfying the equation z equals 3. So basically what that means is that z equals 3 is defining a plane. Imagine you pick up the floor in this gray floor that you see here, and you have this moved up 3 units. That will be this plane z equals 3. Okay. So this is a plane, and it's a horizontal plane. Okay. So this is one of the first challenges, starting to see what the equations mean. The great thing about this is that as we get better at that, we don't need to sketch anymore and just writing the equations better. So we're suffering now, right, through the sketches, so we can later understand and have an image for each sketch without having to draw them anymore and just deal with them with the equation. See, it was a little hard to draw this plane, but writing z equals 3 is not hard at all. So let's see the next example. Now I have z equals 3, y equals 1. Okay. Now the point 0, 0, 3 is not part of it anymore, right? But the point 0, 1, 3 is part of it. So x being 0, y being 1, z being 3 is part of my geometric object, whatever object this is. This point is in there. This is the point 0, 1, 3, correct? But also, all other x coordinates are free to be whatever they want. So not just 0, but 1, 2, 3, like so. So I can move 1 unit forward, another forward, another forward. And also I could have moved backwards like this, right? So what's that really describing? All of those points are a part of my graph, a part of whatever geometric object this is. What is this really graphing? If you stop for a second to understand and imagine what's going on, all points on this horizontal line like this are in this equation, and this geometric object satisfy this equation. So this describes a horizontal line. This is not the best way to describe a line, by the way. Later on, we're going to see that for lines, it's better to use parametric equations, sort of pick a direction that the line goes towards and add a vector, a multiple vector of that direction. But that equation, this set of equations, 2 equations, right? Z equals 3 and y equals 1, they do describe a line, right? This is fine too. Now another one, 2x plus 1. Now, this one's kind of tricky for some people. Here's what this does. If I were in R2 in the plane, what would y equals 2x plus 1 be? That would be a line with slope 2 and y-intercept 1. This would be my object. right? And if you sort of imagine that this red image here on the right is a bird's eye view of the space, of Euclidean space, then you can see this line that I just drew, as y-intercept 1 right here. What will this be? Let me also get this point just so I get some bearings when graphing my line. This point would be when y equals 0. So it would be 2x plus 1 equals 0. It would be x equals -1/2, like so, right? Double check. Seems fine. So it would be this other point here. X equals -1/2. So you'd have a line sort of coming towards us like this. So all points that were on that line, if you just add a coordinate 0 at the end, they're also going to be in the geometric object described by this equation in space. But also everything above it, right? Every sort of copy of this line raised upward a certain number of units, or downward also, right? So if you imagine those copies of the line stacked one over the other, one over the other, one over the other, one over the other, you can see that this needs to describe a plane. So it's kind of a weird angle for a plane, but it is a plane. Okay, so this is a vertical plane. And I kind of like to see this as the z coordinate being free, you know? There's nothing said about z. So sometimes I'll say that z is free. And that helps me understand that if any point in space is in my object, then anything above and below it is also in my object. So that's why this thing is vertical. Z doesn't matter. Okay, got a few more examples for you. We go until f. All right, again, x squared plus y squared equal to 4. If we were in R2 in the plane, you know what this would be? This would be a circle of radius. Let me see if I can cheat to a circle of radius 2. Right, so this would be 0.2, 2, -2, -2 like this. So I'm going to do the same. Here's 2, 2, 2, 2, 2, -2, -2. Right, so 4 circles. And it's not going to look very much like a circle, but again, it's because of perspective. And you can imagine this is like a bird's eye view. So drawing eyes is not my forte. Bird's eye view of this circle on the right here. But again, z is free here. Z is free, which means, again, that everything above and below this circle is also going to be a part of your object, of the geometric object described by this equation. So what does that mean? Imagine, again, as stacks, so copies of the circle. They're not changing radius, right? This is just my inability to draw. Just imagine copies of the same circle above and below stacking on top of one another. What will that generate, right? That will generate a cylinder. That will generate a cylinder. Sometimes this is kind of hard to see. And this is a vertical cylinder. Okay. This is the object described by this equation. There's a sketch and a verbal description. Just the shell of the cylinder, by the way. Just like this equation over here in R2 only described the circumference of the circle, not the interior, then this is going to describe only the shell of the cylinder, right? It's nothing inside of the cylinder. It's not a solid cylinder, right? It's hollow in the middle. I can imagine it's a tank or something, like a cylindrical tank that is empty, right? Right, okay. But it's infinite in both directions. It's also important to say it goes forever up and forever down because there's no bounds to z. I got two more examples. Here's e, x squared plus y squared equals 9. So that should be fine for you, right? Again, if I were in R2, that will be a circle of radius 3. Can I move this? Yeah, there you go. That'll be a circle of radius 3. So then I'd have points 3, 3, negative 3, and negative 3 down here. So I'm going to do the same. There's 3, 3, negative 3, negative 3. And then I'll sketch. But then by doing that, I'll do it anyway. I'll be making a mistake by doing that. Because this circle that's on the screen on the left, this one, this is not the circle I want, right? This should be, again, the bird's eye view of my circle. Because the circle that I want, this is the first part, the circle that I want has z equals 1, right? So this first blue underlined equation is telling me to draw a circle. And this z equals 1 equation is telling me at which height to draw my circle. So my circle is not at this height that I drew here. It is lifted off the ground, right? 1 unit, so floating off the ground. I'm not exactly sure that I'll be able to do this, but I'll try. I'll try and lift this 1 unit. Lift this 1 unit more or less the same. And then you gotta suffer with me through this. And then this, and then I'll try and sort of draw this lifted up circle. Okay. It's a terrible circle, but believe me, it's supposed to be a circle. And then now that I have this, what I can do to make sure that my reader understands what I'm doing is I'll go ahead and label a few points. So weren't these points, look at them on the right, 3, 0, 0, 3, negative 3, 0, and 0, negative 3, right? So I can label a few points just to make sure that my reader knows exactly what I'm doing. So I have the same points here, but with z equals 1. So they'd be, that one would be the point 3, 0, 1. And then we'd have here negative 0, right? Y is negative 3, negative 3, 1. And then negative 3, 0, 1. And then this guy would be the point 0, 3, 1. So these are the 4 points that I sort of make sure to draw. And the center of my circle isn't 0, 0 this time. The center, it will be 0, 0 here in R2, but we have the bird's eye view issue. This will be 0, 0, 1, the center. I'm not going to plot that. The more you plot in 3D, the more you sort of pollute your drawing. So you try and avoid doing too much. Now I'm going to sort of erase the bottom circle, the one that I did on the ground level. And sometimes you can maybe dash it even, project it down to have a little less information, but still convey this depth idea. So this is a circle of radius, say a horizontal circle of radius 3 centered at the point 0, 0, 1. Okay, I hope that describes accurately for you. Now the last example, which I think is kind of bonkers. Again, if you were in R2, if I tell you this, x squared plus y squared is less than or equal to 4, you have to think two things. You have to first think, okay, when x squared plus y squared is equal to 4, what do I get? So you get a circle and of radius 2, of course. But because it doesn't have to be equal to 4, right? you're accepting all radii, right, that are less than 2. So everything here in the middle, everything that's a distance less than 2 from the origin. So you're actually not talking just about the circumference, you're talking about the circumference and the interior of the circle together. Yeah. You could have done this slightly differently, where if you had done x squared plus y squared less than 4, you would not have included the circumference, the shell, only the interior. I'm not going to do that now, but be ready that this could happen too. It's even harder to draw, so I'm not going to handle it now. But that is just the first part of the equation. We have this sort of filled in circle that's not hollow like a usual circle, including the interior. And now more than that, right? Z, what's Z? Z is not just equal to 0 or equal to 1 or equal to 0.5. It is all Z's between 0 and 1. So it's a bunch of Z's together, right? So what's that mean? So again, I imagine this sort of filled in circle. So I'll draw it there. -2, 2, 2. I'll do the blue color here. 2, 2. And then it's supposed to be a circle. And then you imagine, again, it's filled in, right? So it's not hollow. And this is supposed to be stacking for all different Z's, for all of these Z's. We're supposed to be stacking copies of this circle on top of each other. And these are filled in circles. So we don't just get the shell of the cylinder, we get a solid cylinder, right? If that makes sense. We get a solid cylinder. So if you imagine, again, use that analogy that I used before, it is not just the empty tank. If this is a tank, you were talking about the tank and also about the water inside of the tank. So it's a solid cylinder. A solid cylinder of radius 2 and height. This would be height 1. That's the height of the cylinder right here. From the floor, the ground. So that's my cylinder. There's more information that I can give about the cylinder. I can say where it's centered, but I don't want to get too deep into this right now. I'm just trying to give us a loose description so you can distinguish. This is a solid. This here has volume. It has area too. If you want, you can calculate the area by calculating the sort of the side, the lateral area, and as well as the top area and the bottom area, add them together. This has volume, has area. But if you go back to all of the examples we've solved before, this is a circle. It does not have area. It only has length, right? So it's not something with area. Over here, this is a cylinder. Just the shell of a cylinder. It does have area, right? This is infinite area if you include all of the infinite cylinder up and down. But if you bound this here to a certain height, then it will have finite area. You can calculate it, but it doesn't have volume, right? Because we're only talking about the shell of the cylinder. This is a distinction that I think is pretty important. I hope this makes sense to you.